So today's topic is radical equations, and essentially there's nothing different about this than solving a regular equation, except that, let's take a peek here, except that we need to keep in mind that some of these equations are going to have two answers. So let's keep that in mind, and we'll talk about when we get to that. Okay? So just like any operation has an inverse operation, for example, the inverse of adding is subtracting, this way, the inverse of subtracting is adding, multiply and divide are related the same way. We also have squaring and square rooting. Those are the opposite operations of each other. And so we take that into account when we're solving equations that have radicals in them. So, and we're going to remember to check for extraneous solutions. This is an important thing here. Okay, we're going to learn what that means. I also want to encourage you to look at the notes on alexmath.org. If you go under the section called Radicals, that's going to be very helpful to you. So if we think about this, we're going to square both of these because we're still trying to isolate the n. Over here we get 16, and there we get n, and so we're done. I actually need to pull my notes out of here. So that's easy. Here we're going to square everything. That gives me 9. The square root and the square cancel, and I get just a. Here, we're going to square the entire thing and square the entire thing. We get r plus 4 and 16, subtracting a 4, and we get r equals 12. Here again, just squaring, just kind of getting warmed up. Okay, and I should box all of these in. Okay, now let's do something a little bit more complicated. Yikes! What is this? Well, let's just take it one step at a time. Squaring all that. Notice that the square root and the square cancels. The square root and the square cancels. And so here we have 7x. Here we have 8x minus 1. We're going to subtract the 8x. We get negative x equals negative 1, which means that positive x is positive 1. Same thing here, square and square. 2v minus 3 equals v, minus the 2v, and we get negative 3 equals negative v, so v equals 3. Okay, down here, again squaring and squaring, k equals 2k minus 5. So subtracting the 2k, we get minus k equals minus 5, so k equals plus 5. Here you can see how this is going. 10. So I have special pencils that have really soft, any of you office supply folks out there, I'm using a pencil that's a 0.9 millimeter, and it's 2B. This is the softest lead you can buy, and it's the largest lead you can buy. I do that so that it shows up better on the video, but the downshot of that is that it's really hard to erase. So anyway, let's move the x's over. Plus. So we're going to have 2x minus 8 equals 10. Add the 8. 2x equals 18, so x equals 9. Okay. Let's do some more complicated ones here. So squaring this, you see where I got that, because if I squared that and I squared that, now we're into this quadratic territory. that we've learned all about with quadratics, so this is not going to be anything new for you. Solving this for 0, we have to solve for 0 and then use our quadratic techniques to find the answer. So x squared plus x minus 90 equals 0. I see I can factor that, right? I can factor that. And I'm going to get, negative 9 and plus 10, right? Negative 9 and plus 10. This is where we're going to start to see extraneous solutions. So let's check for extraneous solutions. So if this is the case, and as we know from our quadratic techniques, this means that x is 9, and this means that x is minus 10. Okay, but if x is minus 10, and if we plug that in here, what that's saying is that negative 10 equals the square root of something. This is 90 plus 10 is what that's saying right there, right? That's saying that negative 10, that the square root of something is a negative number. That's impossible, right? So this would be impossible. This would be impossible because you can't get a real negative from a square root. That's the whole point in that. If we plug in 9, it does work because 9 equals the square root of 90 minus 9, and as we know, that is the case. So this answer actually, this is good. This one is bad. This one does not work. It's what we call an extraneous solution. Okay? Let's do this one down here. We square all of this. Okay, so solving for 0. I notice that I can factor this and I get x minus 3 and x plus 4. So again, this means x equals 3. This means x equals minus 4. But again, that's going to be extraneous. And this one is going to work. Okay? This one's extraneous. Because again, I can't have the square root of something equals minus 4, and that's what that would be saying, right? So that one's extraneous. Same thing here. K squared equals 2 minus k, so k squared plus k minus 2 equals 0. I know that I can factor that into k minus 1 and k plus 2. Right? Minus 2 plus 1. Right. So this is going to mean k equals 1, and this is going to mean k equals minus 2. That's going to be extraneous, because again, it would be saying that the square root equals minus 2. That can't work. This is extraneous, and this one is a good answer. Oops, sorry, I went off the page there. That one's a good answer. So let's do some more here. Okay, so if we square this, we're going to get 8x equals x squared. Again, solving this for 0, I get x squared minus 8x. And it may help you to put a plus 0 in right there. Just if I move this to the other side, I would just have that, but it may be helpful just to put the 0 in there so you can see that you're trying to get minus 8 and plus 0 out of that. I'll show you the other way you could have done this. If you just brought it to the other side, you would have x squared minus 8x, and you could just use a GCF and have done that, and you would get the same thing. But let's just look at this here. This means x equals 8. I find this is easier for students to understand at first. If you can jump to this and you're okay, then good. But if you need the visual here, we're using the zero product property. X is 8 and x is 0. Now, what do we do with the 0? So let's check it. We got to check our answer. So 8 times 8 equals 8. This is a square root of 64 equals 8. That's good. So this is a good answer. This is 8 times 0 is 0. Square root of 0 equals 0. We have two answers that are right. So we actually have x equals 8 and x equals 0. Both are good. Both are good. Squaring here. Solving for 0. Okay. Seeing 5 and 12, how about minus 5 or 5 and 7, excuse me. Adding those is going to give me minus 12. Multiplying is going to give me 35. So this means A is 5. This means A is 7. And as it turns out, they're both good because I can plug back into the original equation, and I get 5 equals a square root of negative 35 plus 60. And here I get 7 equals the square root of negative 35 plus 84. So here's 5 equals the square root of 25, which is good. And here's 7 equals the square root of 84 minus 35, 49. That's also good. So these are actually both good answers in this one. Let's go on up to something even more complicated, trying to keep the video like less than 15 minutes. So let's do two more. Let's do this one here. So minus 48 plus 14x equals x squared. So 0 equals x squared. Bringing the 14x over makes it negative. Bringing the 48 over makes it positive. So I've got, what have I got here? I've got negative 12 and negative 2. Those are going to give me, no, actually, no, not 12 and 2. See, even math teachers mess up on factors occasionally. What are two numbers that multiply to give me 48? 8 and 6. Oh, of course. Minus 8 and minus 6. Okay. So this is going to give us x is 8. This is going to give us x is 6. When we check them, okay, 14 times 8 is 112, minus 48 is 64. So that is true, so that one works. This one is 6 times 14 is 84. Negative 48 minus plus 84 is going to be 36 equals 6, so that's good, so that one works. And lastly, we're going to do this one down here. So again, squaring this and squaring this, n plus 5 squared gives me that, which is, we're going to FOIL this, notice that. And you can FOIL that, you get n squared plus 10n plus 25 is 6n plus 46. So combining everything, I'm going to move everything, collect everything on the left. So n squared minus 6 is going to give me plus 4, and minus the 46 is going to give me 21. Yep. So we can factor, I see a 7 and a 3 popping out here, maybe a minus 3 and a plus 7. Minus 3 and plus 7, and it'll give me that. Yep. So n equals 3 and n equals minus 7. I'm suspicious that's going to be extraneous, because when we have minus 7 plus 5 equals some square root, this is saying negative equals a square root. That doesn't work, so this one is extraneous. Excuse me, that one is extraneous. This one, 8 equals square root of 18 plus 46. That is 64. That does equal 8, so that one is good.